Okay, we can start.
Oh God, Father, we thank you for today. We thank you for the gift of life you've given us. We thank you for how far you've brought us, Master King of Glory. As we are entering into the next discussion, Master King of Glory, guide us, make us understand whatever we are going to learn, that we understand, oh Lord. Bless our teachers who have been with us from start. Amen.
Okay, so we can start our session. We can start our session and we are going to do some practical work. We are going to have, today in this session, we are mainly going to concentrate on work, force, and power. But our major area of concentration is going to be on work. And by the end of this session, these are the learning outcomes that we must be able to achieve. So by the end of the session, we shall expect that each one of us here has been able to achieve these learning outcomes. So I'm going to, you read the instructions and then I want people to have their videos turned on and then you do what this activity tells us to do. We can have one or two, but whoever will turn on the video, we shall be able to see what you are able to do. Yes. Eh. So feel free. I'm waiting to see who is turning on the video. Then I will stop sharing. And then hope you have read what the activity has told us to do. So, okay, so I'm going to spotlight and I will allow them to, such that people can see what people are doing. That is Joshua. Whether it turns on, I will be able to see what you are doing. Okay, Joshua has put on. Joshua, I'm going to ask you to unmute Joshua. Joshua, can you unmute? Joshua, unmute. Oh, Joshua, you can have it back. You can have it back. Yes, I wanted someone to do for us some activity. Okay, Joshua, unmute. Oh, is it your mic? Joshua, could it be your mic that is failing us? Okay, let me, as Joshua is getting on, I want to see whether Patricia is able. Oh, okay, we have lost. We have lost. We have lost. Okay. So let me put it back. And maybe people, I know you are doing where you are. So you can raise up your hand and you tell us if you respond back, have you been able to do any work, and you give the reason why you think. When you have your book, you hold it and you have it up. Do you think you have done work or not? So you tell us, you feel free to raise up your hand and then you share with us. Raise your hand and then you share with us. Anyone? Anyone who wants to share with us? Okay. Siri, you can unmute. Mhm.
Yes, I've done a lot of work because I've used a specific amount of energy to raise the book.
Okay, you have used the specific amount of energy to raise the book. Thank you. That is one. He has mentioned one word that he has done, he has been able to do work because he has used some energy. Okay, thank you. Jeremiah.
Yes, I've been able to do work because there was force applied.
He has been able to do work because there is some force that he has applied. Thank you, Jeremiah. Any other? Any other? Okay. Any other that has something to tell us? Okay, 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 good. Thank you. Yes, so we are going to continue. So, if you move your hand up while holding the book, have you done work? If yes, why? And if no, why? Anyone to throw more light again? If you move your book up and down, do you think you have done some work? Yes or no? Yes, Jeremiah.
Teacher, when you lift in the book,
Mm,
when you lift in the book, work is applied because you use force and displacement
mhm,
because they are going in the same direction. But if you
mhm.
hold in the book and walking steadily, no
Mm.
work is done.
Wow, wow. Thank you. Thank you, Jeremiah. Thank you. Hope members, you are listening in. He has mentioned some keywords. He has mentioned a word like force. He has mentioned. Now, when you look at my screen, when they say that, have you been able to do work? When you look at this kind of arrow, it is showing you that the book was able, this gentleman moved the book from the position where it was and he took the book up. Now, when you take the book up, we can say that you have done some work. Why? There is some distance you have been able to move. So for you to do work, it means that there is some distance, but that distance always will move in a particular direction. So here the distance we have moved upwards. But also there is some kind of force being applied. So in order for you to do work, it means that there is some kind of movement. There is some kind of distance that you move. But that distance you move is always perpendicular to the direction you do take. So that's what we call doing work. Now, I have here some pictures on my screen. You can first read what my activity is going to be about. You're going to first read about what the activity is going to be about. Okay. So what we are going to do, you are going to be raising up your hand and then you tell us what you think. So I'm going to label the pictures that this is A, this is picture B, this is picture C, and this is picture D. So you raise your hand and then you tell us, what do you think? Do you think there is some work being done or no? And if no, why? So hope you have seen the instruction. So they wanted us that for these pictures we are going to describe the action You first tell us what is taking place in the picture. Then tell us, is there some work being done? Why or not? Okay, we can raise our hands. Okay, I'm going to start with Adrian. Yes, Adrian.
I think picture D, there's no work being done.
Okay, you first describe for us what is taking place in that picture you have chosen, and then you tell us what you think and why.
Okay, in picture D, a child
Mhm.
is swinging.
Okay.
So in this picture, no work is being done because once, okay, the work in the picture D was carried out when the child was beginning to swing. But since the child is no longer using force to push herself, the swing now has inertia, which I think there's no work being done by the child.
Okay, okay. Can we ask? Okay, thank you for your submission. We are going to agree or disagree at one point, but that is very good. Thank you, Adrian. Jeremiah?
Teacher, in picture C, it
Mm.
depends on what they are doing. If they are
Mhm.
moving up and down, then it is work because they're using displacement and force. But if they are just holding the pose down, there is no work
Mm.
being done.
Okay, thank you for that submission. Titus?
I think in picture B, there's work being done because the person is using energy to to carry out a productive activity.
Okay, the person is using energy. Okay, thank you, Titus. And then we have, I don't know whether this is Cyril. Cyril. You can unmute.
Yeah, it's siren.
Okay,
So
Siren. Mm.
in picture B, I disagree that there is any work because force is
Mhm.
energy is being used, but there is no distance being covered. So there is no work being done by that guy in picture B.
Oh, okay, okay. Thank you, thank you. Thank you all for those submissions. I don't know whether we could not have a girl to say something, but I'm seeing Sasha is on the call. I'm seeing Abigail. Where is Samsung? Who led us in the word of prayer? Yes. Patricia, you can say something. Samsung, you can say something. At least we have one girl to tell us what you think for you. Okay, okay, yeah. Now, by the end of this session, we shall have known what does it mean for work to be done? What are the components you look at to say that there is some work that this person has done, that there is no work that this person has done? You have noticed that there are some times when you think, yes, there are times when you think that there is work being done, but actually, when there is nothing that has been done. So, those are the kind of things we are going to be looking at in this session. When do you say that work is done, and when do you say that no work is being done? And for some of the submissions you have made, you are going to come to a conclusion that actually that person was doing work. Because work, we have different directions. The first thing you look at, you ask yourself, is there any distance the person has moved? When you look at this person in this, it was our picture B. When you look at this person, you ask yourself, when he's moving, when he maybe picks the soil from his point up to where he is, was he able to move a certain distance? That may be yes. Then you ask yourself, was this person able to use some energy? That yes. Then you can start thinking. Then when you look at this girl on the swing, you ask yourself, was this girl, when you look at her, was she able to move in a given direction? That yes. Was she pushed by a force? That yes. When you look at the people digging, you ask yourself, when you are lifting the hole, Is there any particular direction you need to look out for? That yes. Do you need to apply some energy? That yes. So you are going to find out that at the end of the day, there are some key components that you look at and then say that there is something being done. What about here? I have other pictures. What about these pictures you are seeing here? This is picture A, this is picture B, this is picture C, and this is picture D. Tell us, is there work being done or no? When you look at the pictures, you must be able to describe the pictures very well. Adrian.
In picture A,
Mm.
there's someone seen climbing a tree.
Uh-huh.
So I say here work is being done because
Mm-hmm.
the child is applying force to move upwards, and yeah.
Okay, okay, okay. Good. Thank you. Jeremiah.
Teacher, for picture B, I said there is
Mm.
no work being done because they are neither using force or displacement to watch.
Thank you. There is no work being done. Thank you. Jodela. Sorry, Jodel, I think. Uh-huh. You can go on. Oh, I'm failing to get her. Samantha. Samantha.
I think in picture C, there is
Mhm.
some work done because there is a specific direction or distance moved and there is some force applied.
Okay. Good. Then thank you, Samantha. Yeah, there is some distance. When you look at the kind of action and what they're doing, you can notice that I don't know the dance, but it seems there is some kind of movement they are going to make. Uh-huh. Yes. Cyril.
In pic-
Uh-huh.
in in picture D,
Mm-hmm.
there are two kids sitting and writing. So they're applying energy, but they're not moving any distance. So there's no work being done.
Okay, thank you, thank you. They are really doing, but they are not, they are in one position. So meaning that they are not moving, no distance being moved. Now, when you look at those different pictures, in these pictures, when you look at B, I agree with the person that there was no work. Much as they are seated, they're just watching. No distance being moved. When you look at this gentleman, it shows that he moved from where he was and then he was going where? Upwards. It shows you that there is some kind of movement. There is some distance he covers. But when you look at him, you can notice that there is some energy being applied. So now, whenever you are looking whether work is being done or not, you need to look at those particular things. Is there any distance being involved? Does this person move in a given direction? But the most important one you ask, is there energy may be applied? But what about the distance, the direction the person is taking? So also those ones, you look at them and then you conclude accordingly. Now, what is work? Who wants to define for us what is work? What is it that who can combine for us those different words we have been using to come up with a definition of what work is? Feel free to search on the internet and tell us what you think work is. Mhm. Okay, I'm going to start with Samantha.
Work is a product of force and the distance moved in the direction of force.
Thank you. What do you mean by product, Samantha?
Like work must be like obtained from force and distance.
Okay, okay. Thank you for that contribution. Yukasha?
Sure. May I think work is that valuable thing that
Mm.
requires energy to be done.
Mm-hmm.
If
Okay. Okay, okay, okay. Okay, Jeremiah, and then Titus.
Work is the transfer of energy that occurs when a force is applied to an object and causes that object to move over a distance.
Okay, okay. Thank you. Lastly, Titus. Oh, Titus, I'm not getting you. Oh, oh. Okay, okay. I'll fail to get Titus. Yes. Now, what our members have mentioned is very true. When we say that the work means the force that you apply, the force that is being applied. We're looking at the product. Product means the multiplication of that force and the displacement that you are working on. So may I ask you to just summarize something from this slide? Something small. Okay. Yes, Jeremiah.
Yeah, from the definition, we can see that the girl uses force. And if you want to know that what you're doing is work, you have to use, from the definition, as you can see, force and distance. So
Mm,
also direction. So as you can see, the girl is using force to push the chair into its position. And
mm,
within that force, there's also a certain direction which he has to face
mm,
in order to reach it. And then for
mm.
displacement, there's a distance which he needs to push the chair.
Okay, okay. Thank you. Thank you. Okay. Yeah. So hope you can see now that the girl is pushing the chair. So there is the direction, like they have told us, there is force, but also the girl has moved a given distance. So we can say that there is some work that is being done. When you look at this gentleman, I have another one here. Someone can tell us something about this gentleman. The gentleman. You tell us, is there work being done? Yes or no? And then you tell us, okay? Uh, Let me first go on. Yes, MJ? Oh,
Sir, I'm now to
yes.
say that there's no work done because
Mm,
he has not moved. He's only applying force, but not the,
mm.
but he has not applied distance. So there's no work done.
Okay, okay, thank you. Samantha, you had a contribution. Thank you, MJ.
Um, I think there is no work done because the gentleman is only applying force, but there is no distance moved.
Very good. So now that particular object is not moving. It's like you. So you are wasting your energy. Much as you are putting in a lot of energy, but there is no movement. And therefore, we say that for this particular case, there is no work that is being done. Thank you. So what are those two important things that are involved in work? Can everyone first type in the chat and we see whether we are on the same page? You type in the chat. What are those two important things that are always involved when you are doing work? Force and distance. Force and distance. Okay. Okay. Distance and force, work and motion. Okay, very good. Very good. But now from today onwards, we shall say, what do you need? You need the force and the distance you move in a particular direction. So may I ask you to summarize something from this slide and then we continue? We are summarizing. Right. Okay. Okay. Thank you. I know everyone has finished now to summarize, and we are good to go. Now we go to the next component, the SI unit of work. Now, the gentleman you see there on your screen is the gentleman behind the concept. And like we have said, that work is given by the force, and we multiply it times the distance, but the best word to use can be displacement. Reason being that force is a vector quantity and displacement is a vector quantity. So when you multiply a vector times a vector, you end up with a scalar. Now I'm going to first ask you, what are the units for force? You put in the chat, what are the SI units for force? What are the SI units for? What are the SI units for force? Newton. Okay, Newton. Yes, people are saying it is Newton. Very good. Now, one thing now I want us to start changing. Are you seeing the way you have typed the word Newton? Whenever something is named after a scientist, when they use your name, let me say they have used Joella, Karen, and other Samantha and the rest, always when we are writing our names, we use small letters. Even when it comes to those whites, when you find a small letter being used, always know that that is like a personal name. And for them, even when it comes to these surnames, let me say Kaziva, Nancha, and Huhu, those ones, they use capital letters. So whenever you find capital letters, those are their surnames. You find Christian names, they use small letters. Now, in science, whenever we are writing any name which has a unit that was named after that person's name, we write using small letters. So when I'm writing Newton, I write like this, Newton. So this is the right way, or Newtons. Because this one has a capital letter as the unit. So whenever you are writing it, write bit in an exam, bit anywhere. Always start with a small letter. This one shows that this person was a scientist who discovered something and it was named after his name. Okay, very good. Yes. Members, what about displacement? What are the units? What about displacement? What are the units for displacement? Or what are the units for distance? Meters. Very good. Very good. I've seen meters. Karen, I've said a capital letter is for the unit. But when you're writing the name of the person, when you're writing in words, you write it in small. But now when you look at meters, in meters is not named after a person. So for that one, we can use capital letter because its unit is small. When you find those small units, those ones we write there. Like now what Samantha you have written, Yukasha, that is very okay. So for them, you can write in there those capital letters. It is okay because whatever unit that is small, you write them like that. So this is going to be Newton meter. Yes, but Newton meter can be combined to form one unit. Which unit do you think that is? Which unit do you think that is? Which unit do you think that is? Joules. Joules. Very good. So those are what we are going to use as joules. Thank you. Thank you. Okay. Remember also joules. Very good. Some of you have now known that joules is a capital letter. Is a capital letter when you are writing it. Is it capital? It is a capital letter. Okay. So can we write it somewhere how these units come about? Can we? And don't forget when I'm writing a geo, I write it like this. Okay, so summarize. When you finish, you let me know. Okay, I think we are good to continue. Okay, people are finished, so we can continue. Okay, so can you first write this in your book, this activity, then we continue. I'm assuming that people have finished. Okay, anyone who wants to take us through? Okay, people have already got the answer. Others have got a different. Who wants to take us through? Okay, Samantha. Yes, Samantha.
Teacher, can you allow me to write on the screen?
Okay, I have no problem. Wow, good. Oh, let no one else write. Samantha, you can go on. Samsung, don't write. let's leave Samantha alone to write. Samantha, go on. Let me first clean. Okay.
In the previous slide, they say that work is obtained by the product of force and displacement. Here, our force is the 500 newtons the woman is using to push the grocery cart, and the distance moved will be 7 meters. So the work will be and the units for work are joules. So the answer will be 3,500 joules.
Wow. Thank you. Thank you so much, Samantha. Yeah, I've also learned. I've also learned. Yes, this is very good. Okay, hope members we can move on. Those who are getting 4, 5, you can check out how you used their calculator. Okay, good. So I have another one. So allow me to clean the board, and then I'm going to first disable because people may write. So let's also first write, and then we try it out. So when you finish, we can have one person raise up the hand, and then you briefly take us through. Yeah, I would prefer someone who, okay. It is okay if you can manage to write on a board, it will be very good. Hmm. Okay. And who wants to take us through? Okay, the answers are correct. The answers are correct, members. Okay, the Nick Woods, unmute.
Thank you, teacher. Teacher, here they have told us to to find the work
You are
done by
writing, right?
Oyo.
Danny,
Yes?
you are also writing, yes?
No, I'm going to talk, teacher.
Can't you write also? Don't you seek a pen? Are you seeing an icon of a pen on your screen?
Yes.
You pick it and also write and we see. Okay. Continue.
Teacher, let me just talk.
What is happening to the writing?
Uh, like teacher, I can't write because I'm using a laptop.
Oh, even on a laptop you can write. Have you got a pen? Have you seen a pen?
Yes. Yes.
Now what you do, you are you seeing the touch where the touchpad is?
Yes.
Then you right click and then you move your letters very well.
Okay, teacher. Thank you.
Okay.
Now, teacher, they have told us to find the work done by Oyo, and we are going to use
Mm-hmm.
the same method
Mm-hmm.
like the one we used at the recent question by saying work. Let's say it. Okay. The saying work equals force
Okay, you can talk. We shall learn later. We shall learn later, no problem. You talk about it.
Okay, by saying force time is the distance, and
Uh-huh.
our force is the weight of the box, the 300 newtons, and
Mm-hmm.
then our distance is the 4 meters. So we are going to multiply the 300 newtons times the 4 meters, then we'll get 1,200 joules.
Mm. Okay. 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 Thank you, Woods. I think we shall have a session, Woods, and then you learn how you can write using our laptops. Okay, but thank you. That one, I know members have got it. Okay. Now this is another one that we are trying out. And I want someone to give us a hint. What is the hidden thing here that you need to observe? Hmm. There is something. Yes, Samantha.
Yeah, we have to change the units of distance to meters.
Okay, the units of distance to meters. Very good. Big boy. Okay, Kenneth, that is okay. Kenneth, I think you have a good handwriting also. I'm seeing you are able. Even last time I saw you being able. Okay. Kenneth, you can change it for us. No problem. You write and change it. Oh, now someone here is spoiling our board. Please don't spoil the board. Let Kenneth first finish. Okay, thank you, Kenneth. Kenneth, continue working out. Continue working out. I have no problem. Continue working out and finish, such that also other members can check out their answer after. Oh, Kenneth. Oh, okay. Another person, feel free to write on the screen. Okay. Yeah, thank you, Kenneth. Members, do we have the same answer? Like what Kenneth has? Thank you, Kenneth. Eh, 36. And do not forget our units of joules. Don't forget our units of joules. Thank you, Kenneth. Yes, so always do not forget to convert to units because units work hand in hand. They work hand in hand. So always, yes, Samantha, that's good. Marvo, Letitia, this is very nice, members. Thank you, Ranta, Jodel, Patricia. Sorry, I can't bear hear anything. Oh, sorry. Nakauka, okay. Okay. Some of you it is freezing. Okay. Even people in Canada saying it is freezing their ends. Okay. So let me see whether I have one more. Okay. This one you can tell us the answer. Mhm. This one you're going to put for us the answer. You're going to put for us the answer. Okay. Marvel. Marvel. Oh, okay. The hand is down. Okay, but looking through the chat, I'm seeing members are getting 800 Jews. Okay, that is very good. Very good, very good, very good. Okay, I think also this one. For this one, write and we do it. This one, I want you to write and we first do it. But read the question to know what they want. Hmm. Okay, I'm looking through the chat to see whether people are doing something. 40. We are not yet safe. I'm seeing some answers. Okay, I don't know who is writing for us on the board now. Who wants to write for us? Anyone? I call on Samantha. Samantha, you write.
Um, Here we will use the formula of work done.
Huh?
Times. Here we have the work done, which is 1,000 joules, and we don't have the force. but we have the distance, which is 25. So we will divide. And this will give us 40, which is the force. But they say that they want the mass. The force is the same as the weight, and weight is equal to mass times acceleration due to gravity, which is equal to 10 newtons. So our weight was 40 newtons. So we'll get the mass times 10 newtons. We divide both sides by 10. And our mass will be 4 kilograms. I think that's the answer.
This point. Okay. Thank you so much, Samantha, for the explanation. And let me hope people have gotten the four. The four. So that's how you work it out. And do not forget the standard units. When it comes to mass, they are kilograms. So you have to write the kilograms. All right. So let me check again. Yeah. So what are we going to do? You are going to give me some 2 minutes and then we do some quiz. We do some quiz. So give me some 2 minutes as I get the quiz and then we start. So join, uh, look in the chat, I've posted the link. So let's join. In case the code is failing, use that code. Members, should we start? Should we start? You can let me know. Let me hope people have joined. I want us to start our quiz. Let me. Donald. Yes, Donald. Are you getting any problem? Okay, I'm going to press now the start button and then we start.
Hello?
Let me tell you. Okay, congratulations, Samantha, Zoe, and our first runner, Samsung. So let me display how we have performed. Okay, I want to check on the report and we see how we have done in the quiz. So you can check how we have performed. Our performance is there. Some of you missed out some questions. Yeah, but that's how we have performed. Yes. Okay. So allow me that we end here for our session, and I want you to utilize the afternoon to do some work at home, and then we shall meet again on Monday. We are going to meet on Monday, and then we are going to meet on Tuesday. Now on Monday we are going to talk about mainly, we are going to have a combined session where we are going to talk about mental health because we understand